So in this video, we're going to talk about percent composition. Now, it's usually, at least in the eyes of chemists, it's useful to know how much of a compound's mass is made up by each of the elements. Okay. Now, percent composition is probably something that you guys heard before when you try to figure out parts to a whole. And the general equation to this, when we're talking about a percentage of something, it's typically part divided by whole times 100. Okay, that's your general um, equation when we're trying to figure out the percentage of something. So when we're talking about percent composition more specifically, all right, and when we say percent composition, we're always talking about percent composition by mass, all right. Different units, we call it something completely different, but in this terms, percent composition, we're always talking about mass. So when we're looking for the percentage of a mass of any particular compound, it's always the mass of the element divided by the mass of the compound, all right, and then multiply that by 100. And that's your mass percent, okay? So depending on what type of info that's given to you, depending on whatever the problem is given to, depends on how we use this equation, okay? So, for example, a 40-gram sample contains copper and chlorine compound. After the decomposition reaction, it was determined that 18.91 grams of copper was left over. Determine the percent composition of copper and chlorine. All right, so here we're just trying to figure out what is the percent composition of the elements copper and chlorine within this 40-gram compound sample, okay? And so to do that, well, we know that of this 40-gram sample, 18.91 grams of it was copper. And so we could use that to figure out what's the percentage by mass that was copper. So we have 18.91 grams, which was copper, divided by 40.0 grams, which was this compound, okay, times it by 100. And so when you do this calculation, you find that it is 47.28% is copper. Okay, so now we got the percentage for copper. Now let's figure out what's the percentage for chlorine. So there's several ways that you could do this to figure this out. So I'll go through each of the different ways you could figure this. Well, if you know that the total thing was 40 grams that contained both copper and chlorine, and you know what was the mass of just copper alone, you could subtract it and you figure out the mass of chlorine. So 40.0 minus 18.91 grams, so both of these grams you have is 21.09 grams, and this is chlorine. Okay, and to figure out what is the percentage of chlorine in the 40-gram compound sample, we'll divide this by 40, times it by 100, and then we find that it is 52.73% was chlorine. Okay, another way that you could have done this is that if you just start out with knowing that you have 47.28% copper, and we know that when we add up all the parts, we should get 100%. Then if you just subtracted this number by 100, you would have also gotten 52.73, or at least really, really close to it. All right, so that's one way that we could figure this out. So let's just say that you are not given any mass data, all right? But you know what is the chemical formula of the substance that we're trying to figure out the percent composition for. So instead of using just a normal mass, we could use the molar mass instead. So for example, here's a question. Determine the percent composition of H2S. All right, so we know what is the chemical formula for this. So we could easily figure out the percent comp for each of hydrogen and sulfur by looking at the molar mass. So we know that H2, all right, its molar mass is, hydrogen has a molar mass of 1.008, and since there's two of them, it's a total of 0.16 grams per mole. We know sulfur has a molar mass of 32.066, and since there's only one of them, still 32.066 grams per mole. And so when we add these up, all right, we'll have the molar mass of H2S. All right, so H2S has a molar mass of 34.082 grams per mole. All right, now if you want to know what is the percent by mass of each of them, all right, we could use the molar masses. And so, like, if you want to know what's the percent of hydrogen, mass by mass of hydrogen, we know that there's two H's, so it's 2.016 divided by 34.082 times it by 100, and that will give you a percentage. All right. And then for sulfur, percent of sulfur, you have it's 32.066 divided by 34.082 times that by 100, and that will give you its percentage. So for the percent of hydrogen, you'll get 5.92%. All right, so that's the percent by mass of hydrogen. And then for sulfur, you'll get 94.23%, which turns out to be for the one for sulfur. Okay, and so this is really how you calculate and figure out the percent by mass.